We're going to talk more about the synthesis of these compounds in class. When we get to 5.10, it's about the synthesis. So we'll talk more about that in class. I like to do those in class. But 5.8 we're going to go over. That's the oxidation of aromatic compounds. All right, oxidation in organic chemistry, we talked about this, means adding oxygens to your carbon. Adding oxygen to carbon. That's basically all it is. It's the number of bonds to oxygen. Okay, so this is the sixth reaction in this chapter, and it's the last reaction. It's very simple. How it works is if you have an aromatic ring and the benzylic carbon, it's got to be sp3 hybridized, all right? And secondly, it has to have at least one hydrogen. Have at least one hydrogen. What can happen is you can oxidize that carbon off. Okay? So, if you have those two criteria, you have to have those two criteria. All right? So that's kind of the generic way of showing sp3 hybridized and at least one hydrogen. If you add KMnO4, we have learned about KMnO4 in water. So if you add potassium permanganate, that should be water, not acid, in water, you can completely oxidize off the whole entire, and it doesn't matter how many carbons you have. You can completely oxidize it to carboxylic acid plus other organic stuff is what I'm going to call it. All right, because it's not important what it is. Okay? So you can have R groups at these positions. You can also have hydrogens at these positions. Okay? You have to have at least one hydrogen. So let me just show you a real simple case. So let's say you have, ethane, all right, and you add KMnO4 and water. You form benzoic acid. End of story. Simple as that. All right. The other carbon, the other methyl group is what comes out as the other organic stuff. Okay? So let me just give you an extreme example, all right, just to be kind of ridiculous, just to kind of show you. So put another group there. We have at least a hydrogen there. Put other groups here and another group here. All right, let's put a cyclohexane at the end. Who cares? All right? So notice what I have here. I got a lot of carbons, all right? But my benzylic carbon is sp3 hybridized and has a hydrogen. As long as it has those two things, if I add KMnO4 and water, you still get benzoic acid. So it's kind of a neat reaction. It cleaves everything off. All the other stuff, again, that's the other organic stuff, not really that important. Okay? So let's do a practice problem. This is tert-butyl. T-butyl. I'll kind of draw it out. I kind of did a shorthand, but let me draw it. That's a carbon right there. And let's put an ethyl group there and a methyl group here. All right. And I want you to add excess KMnO4 and water. Whenever I say excess, we've learned this before, but it just means I have a lot more of it than the starting material. All right, and put on pause, draw what the product should be. All right, so this is the product. Notice this methyl group gets oxidized to the carboxylic acid. This ethyl group gets oxidized to the carboxylic acid. But notice the tert-butyl group does not get oxidized. And why is that? Because there is no hydrogen on this carbon. It's still sp3 hybridized, but there is no hydrogen. Remember, the criteria are both sp3 and hydrogen. So that tert-butyl stays where it is. Okay? And we're going to skip 5.9. We're not going to do it at all. And like I said, 5.10 is synthesis. We're going to get more into reactions, and that's something that we'll save for class because I like to go a lot more slowly, and we'll do a lot more problems like that in class. So that is the end of Chapter 5.